Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, we are given that angle KLM is a straight angle. Angle KLM is a straight angle. What did it mean to be a straight angle? Oh yeah, it meant that it was exactly 180 degrees. So together, 10x minus 5 and 4x plus 3 together are 180 degrees. So we can use the angle addition postulate to say 10x minus 5 plus 4x plus 3 equals 180. And now I'm going to combine my apples and oranges, combine my x's, combine my numbers. 10 plus 4 is 14x. Negative 5 plus 3 is negative 2. And that is still equal to 180. Add 2 to both sides. And 14x equals 182. Divide 14 from both sides, and 182 divided by 14 is 13. So x equals 13. Am I done? Found x. Good to go, right? Wait. I'm supposed to find the measure of angle KLN and the measure of angle NLM. So let's get some different colors in here. KLN is this angle right here. And hey, that's 10x minus 5. So if I just take 10x minus 5 and I take the x we found over here, I can say 10 times 13 minus 5, which is 130 minus 5, which is 125. So the measure of angle KLN is 125 degrees. Now, a different color yet again, the measure of angle NLM. NLM is this angle, which means that it is 4x plus 3. And again, if I take x and I plug it in here, I get 4 times 13 plus 3. 4 times 13 is 54 because there's 13 cards in a suit, and there are 4 suits in a deck of cards, and there are 52 cards in a deck of cards. All of that was to say that 4 times 13 is 52. Plus 3 is 55 degrees. So that is the measure of angle NLM. Are we done now? Yes. Because we have found both things that we needed to find. So there is your entry task. If you struggled with any part of this, please talk to your teacher, talk to a friend, get some clarification before we move on to what we have for today. Today, we will be talking about section 1.6. This is about pairs of angles. So 1.5 was all about introducing you to angles. Now we're going to talk about how angles can interact with each other and some of the pairs of angles. There are many special pairs of angles in mathematics. So your learning target is that you know what different pairs of angles are. You know what they are and what they're called. And the success criteria is that you can identify angle pairs and use them to solve problems. So identify, use, solve problems. Cool. Let's jump right into it. Here are the first important angle pairs you're going to see: complementary and supplementary angles. Now notice how this complementary is with an E. It's not complementary. These types of angles tell you your shoes look nice. These types of angles, complementary, mean something completely different. Complementary angles are two positive angles, must be positive, whose measures have a sum of 90 degrees. Each angle is the complement of the other. So, complementary, when you see this word, I want you to think they add up to 90 degrees. And please put this in your notes. I'm going to get a different color for supplementary. Supplementary angles are similar. They are two positive angles whose measures have a sum of 180 degrees. So these add up to 180. These are so important, and I know I've talked about this. Everything we've talked about so far, I've basically been like, this is important, we're going to use it for the rest of the year. But that's true. This is chapter 1. We are laying the foundation for everything we're going to talk about this year. So, chapter 1, and even chapter 2, very, very, very important that you understand how angles work together, because we're going to keep talking about angles for the rest of geometry. So, supplementary, add up to 180. Complementary, add up to 90. Now, one more thing I want to say. These can be right next to each other. Oops. See how in this picture, the angles are right next to each other. They share this side right here. These angles are still complementary. Even though they're not right next to each other, they are still complementary because 20 plus 70 is 90. So they don't need to be right next to each other in order to be complementary. Just like with supplementary, here you can see how they have this side in common, but these angles are still supplementary because 115 plus 65 is 180. So the angles do not have to be right next to each other. And I would write that down if I were you. Okay, so now that you know what complementary angles are, what supplementary angles are. Oh, I want to say more about the being right next to each other. So when I said right next to each other, we have a fancy name for that. We call them adjacent angles. The word adjacent means right next to. This cup of water is adjacent to me because it is right next to me. My computer is adjacent to me because it's right in front of me. So, adjacent means and next to means next to. So your neighbors are adjacent to you because they live right next to your house, okay, or apartment. So, complementary and supplementary angles can be adjacent or they can be non-adjacent. Very important. This is what I just said about how they can be next to each other or they can be separate. As long as they add up to 90, that's the important part. So, adjacent angles share a common vertex and side, but they have no common interior points. So, these angles are adjacent angles, and you can see that this angle and this angle, they share the same vertex and they share this side right here. So that means they are adjacent. Different color. These are non-adjacent angles because one is over here and one is over there. They're completely separate. So adjacent or non-adjacent means that they're separate angles. Adjacent means that they share a vertex and side. Write this down with me because this is important. And you're going to see why it's important in our very next example. Identifying pairs of angles. In the figure means the picture or the diagram. In the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So we want complementary angles. We want supplementary angles, and we want adjacent angles. Complementary. Complementary means that they add up to 90. So, let's start looking at some angles. 127. That's already bigger than 90. If I add something with 127, it's going to be bigger than 90. So I can't even use that one. That one cannot be complementary because it's bigger than 90. But 37 plus 53, hey, is 90. 37 plus 53 is 90, so that means that these two angles are complementary because they add up to 90. And in fact, I'll put that over here. Complementary add up to 90 degrees. Supplementary add up to 180. And adjacent are next to each other. They're next to each other. So, I just need to name these angles. The complementary angles are... Maybe we should do this in a different color. Angle BAC and angle RST. Beautiful. Okay. Next, we want supplementary angles. And I'll get a different color for this. Supplementary means they add up to 180. And a 180 degree angle looks like a straight line. Do these two angles, they don't make a straight line. Now I can check 127 plus 37 is 164. So this is not supplementary. These two angles are not supplementary because they add up to 164, not 180. So 127 and 37 isn't going to work. But what about 127 plus 53? Ah, that's 180. And you can see that when I slide this angle over and put it right here, I get a flat line on the bottom. I get a straight line on the bottom. So that's another way that we can know for sure that they add up to 180. So, whoops. This angle and this angle. So we have angle CAD and angle RST. Beautiful, beautiful. Because these add to 180 and these add to 90. Okay, next, different color. We want angles that are adjacent to each other or next to each other. So, this angle is not next to any angle. It's just out there floating by itself. Remember that adjacent angles have to share a vertex and a side. That's what makes them adjacent. But these two angles, look at that. They share the vertex A, and they share this side right here. So, angle DAC is adjacent to angle BAC. Ta-da! This is super, super, super duper duper important. I know I keep saying that. Chapter 1. We're gonna use everything in Chapter 1 from now on. Like everything. So please make sure that you understand this. Adjacent angles, complementary, supplementary. Super, super important. Let's check and make sure we were right. BAC RST, CAD RST, BAC, and CAD. And they just named it CAD DAC, same thing. So yay! We were correct. Okay. We have quite a few examples today. This is the next one. We're still using complementary and supplementary. So angle 1 is a complement of angle 2. Remember that that means the measure of angle 1 plus the measure of angle 2 equals 90, because complementary means they add up to 90. Okay, now we are told that the measure of angle 1 is 62. So measure of angle 1 is 62 degrees. And we want to find the measure of angle 2. Oh, well, we know 62 degrees plus the measure of angle 2 has to equal 90 degrees. Measure of angle 1 and angle 2 must equal 90. And if 1 is 62, all we need to do is 90 minus 62 degrees, which is, know this in my head, that is 28 degrees. Now, do you have to write out the equation like this? No, you do not. I thought it might help some people see where the 62 came from and where the 90 came from. But you can also do it all in one step without writing an equation. For example, the measure of angle 3 is a supplement of angle 4. It's not a vitamin. It adds up to 180 degrees. That's what it means to be a supplement of an angle in mathematics. So together, angle 3 and angle 4 make 180 degrees. If one of those angles is 47, all we have to do is 180 minus 47, which is 133 degrees. So that's what angle 3 is. So you can do this in either of those ways. You can do it this way, or you can do it this way. You can write an equation for it and solve the equation, or you can just kind of reason it through. I do not care which way you do it, because the purpose of math class is to reason, is to solve problems. It's not to memorize stuff. It's not to memorize the steps to solving a problem. So as long as you are doing something logical and your reasoning is correct, I don't care how you do it. Cool. Let's check and make sure we were correct. 28, 133. Beautiful. All right. Now, more important information. We talked about two special angle pairs. That's what today is all about. Today is about pairs of angles. The first pairs we saw were complementary and supplementary. Now, I'm going to show you different pairs. We have linear pairs, and we have vertical angles. And actually, let's do different colors like we did last time. A linear pair is two adjacent angles are a linear pair when their non-common sides are opposite rays. And the angles in a linear pair will always be supplementary angles. So, let's break this down. When their non-common sides are opposite rays, what does that mean? Well, notice here, this is their non-common sides, and they are opposite rays. Another way I like to think about this is when you put their non-common sides together, you get a line. Anytime you see a linear pair, linear has the word line right inside of it. So really what you have is you have a line with another side coming off of it. And these two angles form a linear pair because they make a line. And that's why they're supplementary angles, because supplementary angles add up to 180 degrees, and straight angles, or lines, are 180 degrees. So, anything that looks like this is a linear pair. They must be adjacent to be a linear pair. All linear pairs are supplementary. Not all supplementary angles are linear pairs, because they might not be adjacent. Okay, but this is what a linear pair looks like. Again, we are going to talk about linear pairs for the rest of the year. Like chapter 3, chapter 2, chapter 9, all the chapters. So please, 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 remember what a linear pair is. Okay, new color. Vertical angles. Vertical angles. What letter of the alphabet does the word vertical start with? V. Vertical angles. So angles also look like a V, right? Vertical angles happen when you take this V and you extend the V's into an X. Those opposite angles, if I took this V, if I took the V up here and I flipped it upside down, I would get a V down here. So, I know you're like, Miss Dodge, you're weird, this sounds weird, but stay with me. So this V right here, if I flip it upside down, I get this V right here. These are vertical angles. Because it's like if I draw two lines. Actually, here, let's even do this. It's like the two lines I have here form a perfect X. The angle on top and bottom are the same. Vertical angles are congruent. So these two angles are vertical angles, and these two angles are vertical angles. Anytime you have two lines that cross each other, you have vertical angles. One on the top and bottom, and then two on the sides. So they are the opposite from each other. You have an X, the angles opposite from one another are vertical angles. So, two angles are vertical angles when their sides form two pairs of opposite rays. So, vertical angles only come in pairs. Two angles are vertical angles. If I have a line coming out here, now angle 4 and angle 5, this angle cannot be, like, these three angles have to be vertical angle. It doesn't work. Doesn't work. It only works when you have two angles. So 3 and 6. 4 and 5. They come in pairs. Vertical angles come in pairs. You can't have 3. It's just 2. Just 2 angles that are vertical angles. And actually, we'll keep those there. Okay. If you are confused, that's okay. Let's do an example. Let's see an example of some of these things, and it might make a little more sense. So, in example 4, we are identifying angle pairs. We are identifying all the linear pairs and all the vertical angles in this picture right here, the picture, the diagram. So first, let's focus on the linear pairs. Remember, linear pairs are two angles that together form a line. Two adjacent angles, so they have to be right next to each other. So, this is a line I see. I see a line. But, wait a minute. We have 1, 2, 3 angles here. And linear pairs, a pair of objects is two objects. So 1, 2, and 3 will not work as linear pairs. Can only have two angles in a linear pair. So that's not going to work. Instead, let's look at this line. And the reason I'm looking at lines is because they are linear pairs. So we know that they form a line together. So now when I look at this line, 2, 3, 5, that's 3 angles again. That's not gonna work. But, look on this side, angle 1 and angle 4. Together, they form a line, and it's just 2 angles. So, angle 1 and angle 4 make a linear pair. Linear pairs. There we go. Space in between our words. Okay. Are there any other linear pairs? Oh my goodness, I almost missed one. This first line we looked at, the top had 3 angles, but the bottom only has 2. 4 and 5. And because 4 and 5 are adjacent, they share this side, and they make a line. 4 and 5 are also linear pairs. Beautiful, beautiful. All right, now we're moving on to vertical angles. Vertical angles. So remember, these also come in pairs. We're talking about angle pairs in this example. So vertical angles are when I have two lines that cross. So let me find two lines that cross. Here's a line, and here's a line. I don't see any other lines. So this is a ray, remember? Because it starts here. It starts at the middle of all this and goes off in that direction. That is a ray, not a line. Lines extend forever in both directions. They have the arrows on them. So, because these are the only lines, this is the only place where I'm going to have vertical angles. So I see that 1 and 5 are opposite on this V right here. So angle 1 and angle 5 are vertical angles. And on the other side of my two lines crossing, I have 4 and I have 2 and 3. But remember, these are pairs. Vertical angles come in pairs. So we can't say anything about the other pair because this is 1, 2, 3 angles altogether. So just 1 and 5. Just 1 and 5 for the vertical angles. Let's check and make sure we were correct. 1 and 5 are vertical angles. To find vertical angles, look for angles formed by intersecting lines. And this is exactly what we did. These two lines right here are intersecting. And so we didn't look anywhere else for vertical angles. We just looked at intersecting lines. Excuse me. Now for our linear pairs, we looked for adjacent angles. Adjacent angles that make a line. That's what this means. Non-common sides or opposite rays, they make a line. So 1 and 4, 4 and 5, that's what we said. Booyah! Got it right. Okay. Example 5. Aha. So now we are finding angle measures in a linear pair. This example is important because it shows all of the special properties about linear pairs. So, two angles form a linear pair. I need a picture. Two angles form a linear pair. That means they form a line. And, they look something like that. This is what a linear pair looks like. So I'm just drawing a generic diagram of two angles that form a linear pair. The measure of one angle is 5 times the measure of the other angle. Find the measure of each angle. Okay, we need to come back to this. The measure of one angle, so let's see. 1, 2. The measure of one angle is, and is like equals, is 5 times the measure of the other angle. Okay, that was easier than I thought it was going to be. So we have the measure of one angle is equal to 5 times the measure of the other angle. Okay. Okay. Now what? There's got to be something more. Ah! Linear pair. What's so special about a linear pair? It creates a line. How many degrees are there in a straight line or a straight angle? There's 180 degrees. So, we know that the measure of angle 1 and the measure of angle 2 together have to be 180 degrees. Because they form a linear pair or a line, and lines have 180 degrees. So together, measure of angle 1 plus measure of angle 2 equals 180. And I know that the measure of angle 1 is equal to 5 times the measure of angle 2. So instead of writing measure of angle 1 right here, let's write 5 times the measure of angle 2 plus the measure of angle 2 equals 180. Now here I have 5 measure of angle 2's, and I have another one, so I can combine these into 6 times the measure of angle 2 equals 180. And then if I divide by 6, I get that the measure of angle 2 is equal to 30 degrees. Booyah! Booyah! This is good. This is very good. Measure of angle 2 is 30 degrees. And now I know that the measure of angle 1 is 5 times that much. So, different color. Let's get a different color. So the measure of angle 1 is equal to 5 times the measure of angle 2, which is 30 degrees. So the measure of angle 1 is 150 degrees. Now we can check. One angle is 5 times as big as the other. Well, 30 times 5 is 150. So that checks out. Beautiful. We found the measure of each angle. Measure of angle 1 is 150, and the measure of angle 2 is 30. Beautiful. Awesome. Let's check and make sure we were right. X and 5x. Okay, we used measure of angle 2 instead of x, but the same thing. 6x equals x equals 30, 150. So the measures of the angles are 30 and 150. Yes. Need 2 eyes. There we go. Woohoo! Okay, there we go. That is the whole video. That is all of the questions, all the examples, all the information that you need for today's lesson. So, if you have questions, remember, questions are very good. Questions mean that your brain is growing. And mistakes means that your brain is growing. Making mistakes means that your brain is growing. I make mistakes all the time, so it's okay if you do too. Please ask your questions. Always ask questions. All right. There are a lot of practice problems because we went over 5 examples today. So there's example 1, there's example 2, and then on the next slide, there's example 3, example 4, and example 5. So all of these problems on the last slide and this one are problems that you can do to practice the skills you have learned in this video. Remember to still do your teacher's homework. Don't just do these problems, do the homework that your teacher has assigned as well. And now, let's end our video with a launch, as usual. This one comes from Maya Angelou. She is a wonderful, famous lady. And she says, try to be a rainbow in someone else's cloud. So you know what it means. When people have clouds in the cartoons, they depict people with clouds above their heads. They're people that they're having not such a good day. Their sunshine is covered up with these clouds. They're not doing so great. Be a rainbow to them. Be a rainbow in their cloud. This can be as simple as smiling at someone when you're walking down the hallway. Or smiling at somebody in a Google Meet, maybe. I had a friend in high school that she told me one day, she said, Michelle, you always smile at me. Anytime you see me, you make eye contact and you smile at me. And that really brightens my day every time, to know that somebody wants to smile at me. So now I smile at everybody. I make eye contact with everybody and smile, just in case it helps them. So yeah, the little things. Little things. Also, I had a friend in high school that made me a cake. We weren't even that great of friends, but he made me a cake for my birthday, and I had never had a friend in school like bring me a cake before. And I felt super special that he would do that for me. Now, I'm not saying to make everybody a cake, but if you have a friend that you think might appreciate that, be a rainbow in their cloud. Brighten their day by doing something nice. So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.